There are three main rules as to how we manipulate logarithms. The first is the addition rule, which gives us that the log to the base a of x plus log to the base a of y is equal to log to the base a of x times y. Now I'm putting the arguments of the log functions in brackets because modern calculators do require, for accuracy, for you to do that. The second one is the subtraction. This time, if I have the log to the base a of x minus the log to the base a of y, that results in the combination of log to the base a of x over y. And finally, I'll call it the coefficient. If I have p log to the base a of x, that is the same as log to the base a of x to the power of p. I usually show this one as p simply because it doesn't have to be a whole number, and some textbooks show it as n, and students often get the wrong idea. So these are the three rules that we're going to be using to manipulate logarithms, and what follows is an example of how to combine a series of logarithms into one log, which is a question favoured by examiners. This is the question that we're going to attempt. We want to express this as one logarithm. So we're going to combine, using the rules I just mentioned, into one logarithm. The key to doing this is to ensure that these coefficients, a half and 2/3, are placed into the logarithm using the third of the rules, the coefficient rule I mentioned earlier. So I'll rewrite this now as log to the base a 12 plus log to the base a of 9 to the half. The coefficient outside becomes the power inside, and minus the log to the base a of 8 to the power of 2/3. Again, coefficient outside becomes the power inside. This then gives me log to the base a of, and now I can combine all of these according to the rules. The addition rule means that the 12 is multiplied by 9 to the half, and the subtraction rule tells me that 8 to the power of 2/3 is going to be divided. So I either use a calculator on that, or because these numbers have been chosen because they're quite friendly, which often happens in exams, you're going to have 12 times 3 over the square of the cube root of 8, which is 4. So I end up with the answer, which is log to the base a of 36 divided by 4, 9. The important thing to stress here is that you should always put the steps in that I've put. If you try and leave steps out, you've got a problem. The examiners are looking for that bit of information there. That's absolutely critical. Because they know you have calculators, what you mustn't do is to jump from there to there. You can always do these on a calculator by putting numbers in instead of a, and you can always check then that the thing is going right.